Alright, we're going to talk about arc length and sector areas today. First one we're going to talk about is arc length. When we talk about arc length, we're talking about a piece of the circumference of a circle. So the circumference is the distance around a circle. The arc length will be the length of an arc, which is part of the distance around a circle, or a piece of the circumference. We have a proportion that we'll use to find arc lengths. Arc length over circumference equals central angle over 360. And in each one of these, it's like a percentage. It's the part over the whole. So the central angle will give you, if you know the central angle, we'll know what percentage of the circle we're dealing with as we put that part, that central angle, over the total of 360 degrees in a circle. The arc length is part or a piece of the circumference. So we're putting the part over the whole. So the circumference is the whole way around, and the arc length is just part of the way around. So each one of these is giving us the part over the whole. They should come out to that same percentage, and so that's why they're able to be equal to each other. All right, so looking at example 1, it says find the length of arc EF below. Now remember, if it's named with 2 points, that's a minor arc, so it's less than 180. So I know we're going the short path from E to F, not the long way. All right, so following this proportion we just talked about, arc length over circumference. So I don't know the arc length. I'm trying to find that, so I'm going to use a variable for that. And I don't know the circumference yet, but I can find it. Circumference is 2 times pi times radius, or pi times diameter. So here the radius is 6. So I'll plug 6 in for the radius, and I can find the circumference now. And the direction said to round to the nearest tenth. If it had said to keep it in terms of pi, I would just not type pi in the calculator, but leave it next to the number. But we are going to round to the nearest, I said tenth, nearest hundredth. Now, if I want to keep two numbers after the decimal point at the end of the problem, I'm going to keep a few extra in the middle of the problem. So for right now, I got 37.6991. And we'll leave it like that for now. If I round to the nearest hundredth in the middle of the problem, it might affect my answer at the end. And then we want the central angle, which is 120 degrees, over 360, because there's always 360 degrees in a circle. So now here's the proportion. I can cross multiply to solve for x, which is representing the arc length. So we got 360x equals, you want to multiply this way, let's see what we get. We get something along these lines, depending on how many numbers you're keeping at the time. And then if I want to solve for x, it's being multiplied by 360, so we divide by 360. Now, because this is a simple proportion, if you don't want to take the time to write out this equation like I just did, then you can save yourself a little time by just multiplying these two numbers and dividing by that one. Alright, so here's the number I got. If we are rounding to the nearest hundredth, I'm keeping two numbers after the decimal point. That third number is bigger than is 5 or bigger, so it's telling me to round up. So I'll increase my last number by 1, so that 6 right here will become a 7. And this was in feet. And arc length, just like circumference, is a single dimension, and so it's just regular units, so just feet. All right, let's look at example 2. Find the length of arc LM below. Round to the nearest hundredth. All right, so we want to find the arc length. We don't know it. Arc length over circumference. I need to know the circumference of the circle. 2 times pi times radius. And in this case, the radius is 3 yards. So 2 times pi times 3. Again, we're rounding to the nearest hundredth. At the end of the problem, so I'm going to keep a couple of extra places for now. So there's the circumference. So arc length over circumference equals central angle over 360. Now if I'm finding arc LM, this is the central angle I want. What they gave me is that this arc is 300 degrees. Remember, 360 degrees in a circle. That means that if this is 300, this has to be 60. So the central angle is 60 degrees over 360 degrees for the entire circle. So same thing every time. Arc length over circumference, central angle over 360, and then we just cross multiply. So I'm multiplying these two numbers and dividing by 360. I get something along these lines. If we're rounding to the nearest hundredth, I want two numbers. That one is not big enough to round up, so I get approximately 3.14, and this was in yards, so don't forget to include the units. So that the length of this arc is approximately 3.14 yards. Alright, let's talk about sectors. A sector is like a slice of a circle bounded by two radii and an arc. So think about when you have a pie and you cut a piece of pie, that would be a sector. You think about a pizza and you slice up a pizza, the traditional way at least, that would be a sector. Anytime you have a circle and you draw in two radii and then that arc that it intersects, those create this sector here. So this space right in here, this is a sector. Now, I'm shading stuff in for you because the copy did not come out shaded very well. So I will just shade for you. Another direction say find the area of the shaded sector below. So on each of these problems, I'll just shade it in for you so you know which one we're talking about. And we do want to round to the nearest hundredth. So we're going to follow this proportion. Now it's very similar to what we did when we were doing arc length. We're still in our proportion. Each ratio is representing the part over the whole. So notice this part stays the same, central angle over 360. Because by doing that, we find out what percentage of the circle we're talking about. The difference is we're no longer talking about the length of an arc. We're not going the distance around the outside. We're now talking about area. So the area of this sector is part of the area of the whole circle. All right, so when we're doing this, we want to find the area of the sector. I don't know what it is. Put a variable there. We want to put that over the area of the circle. So this time, where we did arc length, we were finding circumference. So arc length was part of circumference. Now we're doing sector area. That's part of the area. So now we're finding the area of a circle. And the formula for that is pi r squared. And the radius is 6. So I'm putting in pi times 6 squared. Again, I'm going to keep a couple of extra places for now because I don't want to round to the nearest hundredth until I get to the end of the problem. So there is the sector area over the area, and then we want central angle over 360. So 120 over 360. So there is the proportion, and we just have to cross multiply. So I'm multiplying these two numbers and dividing by 360. And then we want to round to the nearest hundredth. Keep two numbers after the decimal point. Now that number is big enough to round up. Now if I increase my last number by 1, it becomes 10. So I put the 0 here, I have to carry the 1 over. Just think of it as 69. If I increase it by 1, it's going to become 70. And this was in meters, so that would be meters squared. Because now we're dealing with area, and area is a two-dimensional measurement. So we make sure all of the units get squared. All right, example 4. Find the length of arc AB and the area of the shaded sector. So now we're doing both things. So let's start with the arc length. Arc length goes over circumference, which I don't know yet, so we need to find it. Circumference is 2 pi r. The radius is 3, so we got 2 times pi times 3. And there's the circumference. So arc length over circumference, and then central angle over 360. And sorry, I told you I was going to shade it in for you. This is what we're shading in for the sector later. And right now we're doing the length of arc AB. We're doing this right here. So we're using the 20. So here's our proportion for arc length. Arc length over circumference, central angle over 360. So I'm multiplying these, dividing by 360. So the arc length comes out to approximately this number. And we are going to round that to the nearest hundredth. That 7 is big enough to round up, so that 4 will increase to a 5. And this is in centimeters. So there's arc length. And now let's do sector area. Now when we set up sector area, I'm going to use Y for sector area since we already used X for arc length. Sector area goes over total area of a circle, so I need to know the area of the circle. So area is pi r squared, so that's pi times 3 squared, which is 28.2743 approximately. Again, if we're rounding to the nearest hundredth at the end of the problem, I'm keeping a couple extra in the middle of the problem. So here, sector area, which I don't know, over the total area, and then central angle over 360, which is still 20 over 360. So again, here's our proportion. We cross multiply. Multiply these, divide by 360. Alright, you're going to end up with something like this. When we round to the nearest hundredth, that 0 is definitely not big enough to round up. So we got 1.57, and that was in centimeters. Area will be centimeters squared because it's a two-dimensional measurement. Alright, example 5. And let me shade in the proper section for you here. This space should be shaded in. Alright, it says find the length of arc AB and the area of the shaded sector, round to the nearest hundredth. Same process we just finished doing. Now, if you want, we can go ahead and find circumference and area at the beginning. We're going to need them anyway. It's 2 times pi times radius. The radius here is 5. So we got 2 times pi times 5. And here is the circumference. And then area is pi r squared, and the radius is 5. So pi times 5 squared. The area is 78.5398. Alright, so we got circumference and area. So if I want to find the arc length is part of the circumference. And then we want to put the central angle over 360. Now be careful not to use that 210. We want the central angle that goes with this arc. So to find that, remember these should all add up to 360. So I got 360 minus 210 leaves me with 150. So I know that this angle right in here is 150 degrees. So 150 over 360. Arc length, which we don't know, over circumference, central angle over 360. Cross multiply. Multiply those, divide by 360. And that will give you 13.08997. So if we're rounding to the nearest hundredth, that 9 is definitely big enough to round up. So we'll get 13.09. And the units here are feet. And arc length, just regular units, so feet it is. Alright, for sector area. The sector area is part of the total area. And then central angle over 360. So there's our proportion. We multiply here, divide by 360. And the sector area is 32.7249. If I'm rounding to the nearest hundredth, that 4 is not big enough to round up. So 32.72, and that was in feet. So area, feet squared. All right, let's look at example 6. This says find the measure of angle AOB. I want to find the measure of this angle right here. Now, this is a little different than what we've been doing. Typically, on the previous examples, they've given us the central angle, and we've had to find the arc length or sector area. Well, this time, what they've given us, they gave us the radius, and they gave us this. Notice there's not a degree symbol, it says inches. So this is not a measure of the arc in degrees, this is the arc length. Alright, so think about your arc length proportion. We put arc length over circumference and central angle over 360. Well, let's substitute in everything we know. We know the arc length this time is 8 pi, We don't know the central angle. That's what we're trying to find this time, is angle AOB. We're trying to find the central angle. And just like we've done on all the other ones, while we don't have the circumference yet, we can find it. Circumference is 2 times pi times radius. And the radius here is 16. So we got 2 times pi times 16. Alright, excuse me. Wait. Excuse me. So you should have something approximately like this for the circumference. And notice now, once we've plugged in everything we know into that proportion, that central angle is the only variable. It's the only thing we don't know. So we can find out what it is by cross multiplying. So we're doing 8 pi times 360. And then dividing by this number. And if you do it correctly, you should get 90 degrees. So I know that the measure of that angle is 90 degrees. Alright, let's look at the last example here. It says the area of sector AOB is 432 pi feet squared. And the measure of angle AOB is 120 degrees. Find the length of the radius. Alright, so think about sector area. With our sector area, we do sector area over the total area of a circle equals the central angle over 360. So let's plug in everything we know. We know the area of the sector is 432 pi. We do not know the area of the entire circle. We do know that the central angle, the measure of angle AOB, is 120 degrees. And 360 always goes down here. So when I set everything I know into that proportion, I only have one variable. I can solve for that variable. So I'm multiplying 432 pi times 360 divided by 120. Now, we are not done right there, though, because that variable was holding the place of area. It's representing area. What we found is the area of a circle. We didn't find the radius, which is what they asked us for. So let's think about the formula for area of a circle. Area is equal to pi r squared. What we found was the area. So that number is equal to pi r squared. Now, once I've set that equation up, the r, the radius, is the only variable, and we should be able to solve for the radius now. It's being multiplied by pi, so the first thing I would do is divide by pi. And when I do that, I find out r squared is equal to 1,296. And then I want to get rid of that squared, so we do the opposite operation and take the square root. And when I do the square root of 1,296, I get 36. So the radius has to be 36 feet. Area was in feet squared, so the radius, one dimension, would be feet.